Hi, my name is Bert Hedberg. I'm inventor of the Centrifan PE. It is a personal evaporator, uses no vacuum, no blowdown, no external blowdown gas flow. It has a condenser integrated with the system, so it actually collects 100% of the solvent that it evaporates. Temperature control, off timer. It's a very convenient evaporation tool for your laboratory. It is a fabulous companion for rotavap capacity, which may exist in your lab. My main purpose for the video is to address a number of questions I get over and over again from customers I talk to, people I met at ACS or PitCon, and I've been speaking with them on the phone over the last few months. I thought it might make sense to try and cover a number of the common questions in this sort of format to try and get as many issues as possible out on the table to make it easy for you to understand how the Centrifan PE can benefit your laboratory. What solvents can you use with the Centrifan PE? To answer that question, let me borrow a page from Tim Russert and Ross Perot, who used charts like this in various times, mostly political campaigns, I guess, but the chart shows a number of different solvents that we've tested the Centrifan with. We go all the way from very volatile solvents like hexane, ethyl acetate. It can do ethyl ether. We've got methanol, water here, go all the way down to DMSO, can even do DMF. Works particularly well with the high boilers because it's not a vacuum system. It is essentially a self-generating blowdown system, and in the process of having the air molecules wipe across the surface, you actually get a higher evaporation rate than you do in a vacuum environment. How does the Centrifan PE work? The Centrifan PE uses self-generating blowdown to cause evaporation of the solvents that you put inside. The spinning fan with the sample containers in the center is what causes the airflow through the system. As the fan spins, airflow jet comes out, perimeter of the fan, circulates around across this heater in the lid, it's warmed, and it's driven down into the sample containers. And the rotors, sample rotors, are just changed by lifting them out and doing a screw. This one has library vials. We've got Eppendorf tubes here. We do 20 mil vials, 30, 40 mil scintillation vials. Also have a rotor insert that does test tubes. And the self-generating blowdown gas from the spinning fan causes the evaporation in the containers. The vapor content of the gas being recirculated is partially sent across to this cold trap. So there's about 10 to 20% of the flow, the gas flow generated by the fan, is sent through the cold trap. The vapor condenses out of the gas flow in the frozen, the cold environment here, drips into the round bottom flask, effectively drying out the gas flow, so that the gas that returns to the Centrifan is drier than what exited. Keep this process up long enough and you get a wholesale transfer of the liquid from the sample containers to the round bottom flask. How fast do the solvents evaporate with the Centrifan PE? Going back to my Ross Perot card, this table here, the solvent table, just some examples if you get a feeling for it. Methanol here, 6 vials, 10 mils each. 40 degrees C, 60 minutes, about an hour for a rotor full of methanol. Water, dried down 6 times 5 mils here, took 3 hours. Hexane, about 15 minutes. DMSO, 6 times 1 mil, DMSO, 40 degrees, 12 hours, basically an overnight run. What solvent containers can be used with the Centrifan PE? The Centrifan PE will accommodate a number of different containers. Again, the containers are switched out just by changing the rotor insert. We've got Eppendorf tubes. We do three sizes of scintillation vials, 20, 30, 40 mil scintillation vials. I've done custom rotors for clients, pre-barcoded library containers. And we've got a couple of different test tubes. I think I'm doing 15 mil Falcon tubes. Best is to check the website. The rotors are all described there. The current selection available is on the web. How much solvent will a vial spinning in the Centrifan PE hold? Because the pockets in the rotor are fixed, it's necessary to position the vials at a 45-degree angle to start so that the liquid can go from surface being horizontal to surface being vertical. So safety factor, you could say 50% full. Putting 10 mils in a 20 mil vial gets nowhere near the mouth. You could probably stretch it to 11 or 12 mils, and you still wouldn't be in the region of the threads. So the rule of thumb is roughly half the volume of your sample container. Why doesn't recirculating evaporation cause cross-contamination among the sample containers? The Centrifan PE dries by self-generating blowdown. As the fan spins, it's generating its own gas flow. The gas flow obviously is shared amongst all the containers that are spinning inside. What you have circulating in the instrument is the volatile solvent vapor. So you've got the gas flow plus any volatile components. Obviously the volatile components are going to be shared amongst all the glassware. Anything non-volatile, say over 150 molecular weight, because of the centrifugal force, stays locked in the bottom of the glassware because of the spinning rotor. So the non-volatile components cannot move from container to container. The volatile components will be used in the evaporation process among all the containers. Eventually the vapor will move over to the cold trap and be collected in the round bottom.